Hi, this is a question on permutations and combination with some idea of how numbers work. This came up in CAT 2020 slot 2. I would suggest pause this video, try to solve this question on your own, and then proceed with the video. Okay. So this one says how many 4-digit numbers, each greater than 1000, each having all 4 distinct digits distinct, are there with 7 coming before 3. So the number 7 should come before the number 3. So you can have 7315. This is a valid number. You can have 4703. This is also a valid number, right? But 7014 is not a valid number. Even though 7 is in the first place, there is no 3. Right. Similarly, 4013 is not a valid number. Why? Even though 3 is in the last place, there is no 7. Right. So herein lies the problem. You need to first ensure that both 7 and 3 are present. Right. And then make sure that 7 comes before 3. Now, we will do it in two different ways. We'll do it using individually counting, and we'll do it in another way possible. So I'll try to describe both of them over here. Both of them will take you roughly about 2 minutes from the time you actually get a hang of what you should be doing. So let's get in. So the first way that we can do is, let's find out all the numbers which have 7 and 3 in them, and they are 4-digit numbers. So it should be a 4-digit number with both 7 and 3 present on them. Right. Now, this part, that the number should be greater than 1000, is automatically guaranteed, because the smallest 4-digit number which has all 4 distinct digits is 1, 2, 3, 4. Right, that is greater than 1000. So we don't need to worry about whether the number is going to be more than 1000. All we need to do is check whether it's a 4-digit number or not. So we first need to find a 4-digit number. Right. So out of the 4 digits, 7 and 3 are already chosen. The remaining 2 digits have to be chosen. So 8C2 from the remaining 8 digits. Right. Right. So how many numbers can be formed here? So 8C2 ways of choosing 2 additional digits. 7 and 3 are already there. Into, once you have chosen the 4 digits, 4 factorial. Will this give you a 4-digit number, a valid 4-digit number? One such number would be 0734. Right? I could have chosen 0 out of those 8 and done that also, right? So this has a problem that 0 is coming up over here. Right? So I need to remove the numbers which start with a 0. So just like with this, I'll have 7, 3, and I have also chosen a 0. So I need to choose the last digit out of the remaining 7. 7, 3, and 0 are gone. So I have 7 choices. 1, 2, 4, 5, 6, 8, 9. Out of these 7 digits, I need to choose one more digit. So that will be 7C1 ways. Now, I need to make sure that the number starts with a 0. Right? So the first place is fixed. Right? So remaining 3 places can be filled in 3 factorial ways. Right. If I subtract this, how much do I get? So I will get 8C2 is 8 into 7 divided by 2. That's 28 into 24 minus 7C1 is 7 into 3 is 42. Right. So if I take 42 common, right. So there is a 7 here and a 6 here. 7 and 7, this will give me 4. Into 4 minus this one, right? So I'll get 42 into 15. Now these many numbers have both 7 and 3 in them, do not start with a 0. They have 7 and 3 in them and they don't start with a 0, right? But they are all not valid numbers. So some of them will have 7 ahead of 3. Some of them will have 3 ahead of 7, right? So I know, because 7 and 3 can both come without any restrictions now, right? Half these numbers would have 7 before 3. The other half will have 7 after 3. So the final number I will need will be half of this, which is 21 into 15. Right? 20 into 15 is 300, 300 plus 15. So 315 will be your correct choice. So that is the first method. Now, the second method that we can do is basically split this into different parts. So one part would be where 7 comes here, right? And then I have to fill the rest of the number. The second case would be 7 comes in the second place, and 3 comes in these two places, then I have to fill the last remaining digits. And the third number will be of the type 7, 3. Okay, so let's calculate them one by one. Here, the first place, we have used up 2 out of the 10 digits. So we have 8 digits left, but not all 8 digits can come here. So the first place can be filled in 7 ways. Second place can be filled in again 7 ways. So this will be 49 numbers. Okay, here 3 has to come in one of these two places. So 2 ways, right? Again, you will have 7 ways of filling the first place and 7 ways of filling the remaining place. So 49 into 2. And in this case, you will have 3 has to come in one of the 3 places. So 3. And the remaining 2 places can be filled in 8 into 7, because you don't have to worry about 0 coming in the first place. So 8 into 7 ways. So let's add this. This will be 56 into 3 plus 98 plus 49. 98 plus 49 is 147, and 56 into 3 is 168. So total will be 15,315. Both the cases, the answer is the same. Whichever way you want to do it, you want to first figure out numbers which have both 7 and 3 in them, and then remove 0 and then divide by 2, or you can individually work this out. Both works whichever way you want to work it. Only thing you need to be careful about is you need to ensure that both 7 and 3 are present. Right, that is a key point on it. Even before you start with 7 has to come before 3. You need to first ensure that 7 and 3 are both present. It's a moderate level question, slightly calculation intensive, slightly over 2.5 minutes to solve in an exam situation. That completes this question.